All right, we are going to evaluate the difference quotient. Here's our function and our difference quotient right here. So I'll just get right in on it. I'm going to start with this f of 3 plus h. I got to substitute 3 plus h in for x in each instance here. So I'm going to do that now, and then we're going to simplify this. So I'm going to have to do this in a few parts. So first off, f of 3 plus h is equal to 4. So what I'm doing is I'm substituting. It's 4 plus 3 times x, but it's not going to be x. Instead of x, it's going to be 3 plus h. Instead of x here, it's going to be 3 plus h as well. So 4 plus 3 times not x, but 3 plus h minus not x, but 3 plus h. And that whole thing has to be squared because x is squared right here. Okay, so I'm going to simplify all this. And that is 4 plus, this ends up being 9. And then that is plus 3h. And then this I'm going to do over here, 3 plus h squared. What that means is 3 plus h times 3 plus h. And if you distribute this, that is 3 times 3, which is 9. This is 3 times h, which is 3h. This is h times 3, which is also 3h. And then that's h times h, which is h squared. And 3h plus 3h is 6h. And then that's plus h squared and 9. So what you have to be careful of is you have to see that this is minus 9 plus 6h plus h squared. So to rewrite this again, it's 4 plus 9 plus 3h minus 9 minus, because that negative gets distributed to each of those there, minus 6h minus h squared. So now we can combine like terms. These two cancel each other out, and these combine to get you negative 3h. We have minus h squared that didn't combine with anything, and we have 4. So that is f of 3 plus h. I'll write that up here. So f of 3 plus h is equal to that. The next thing we need to know is, what is f of 3? Well, f of 3 is equal to 4 plus 3 times 3 minus 3 squared. And 4 plus 9 minus 9. Well, that's just equal to 4. So now when I clean all this up, I'll do that right now. So now what we got is we have, with our fraction bar, we have f of 3 plus h, which is, as I wrote down there, 4 minus 3h minus h squared. And then we have minus f of 3, which is 4, all over h. So further, what we can do is we can have the 4 minus 4, which is nothing. And what we're left with is negative 3h minus h squared all over h. And then what we can do is we can factor out an h from the numerator. So what we're left with is, in fact, we can factor out an h. So what we're left with is negative 3. And then that's h minus h over h. And the h's can cancel. And we're left with a final answer of negative 3 minus h. There's one of them. All right, here, so the next function is x cubed, and I'll start in with f of a plus h, and I'll finish that off. So f of a plus h is going to be a plus h to the third power. And that simply means a plus h times a plus h times a plus h. So if I distribute the first, that's a squared plus a h plus ha plus h squared. So that's distributing all four of those. And this is 2ah plus h squared, and that's a squared. But then this has to be multiplied by a plus h again. So if I go to the first two here, multiply a squared times a, that is a to the third, and then a squared times h is plus a squared h, and then I'll multiply 2ah times a, so that's plus 2a squared h, and then 2ah plus h, so that's plus 2ah squared. And then finally, I have multiplying h squared times a, which is h squared a, and then finally plus h to the third. So that is h to the third. I need to simplify all this. So what that ends up being is I have a to the third. That's taken care of. How about a squareds? I have this one here. So this is a squared h and 2a squared h. So I'm making sure that that's, yeah, that should be right here. That should be plus 3a squared h. And then if I combine these two here, that's, so when I put 2a squared h plus another h squared a, that would be 3 h squared a's, and then plus h cubed. So that is what we get for x of a plus h. Now f of a is going to be, since our function is x cubed, f of a is going to be equal to a cubed. And so putting it all together, we have f of a plus h, that is, again, a to the third plus 3a squared h plus 3h squared a plus h to the third. Oh, and then minus a to the third, because that's f of a, all over h. So what I see is I can cancel these out. And then I'm going to factor out an h. So if I factor out an h, that means in the first I have h times 3a squared. I'm looking at this right here. So I'm looking at, if I factor an h here, I have 3a squared here. If I factor out an h here, I have 3ha. So that's plus 3ha. And then factoring out an h here, that would be h squared. So plus h squared. All over h. So these h's will cancel. I'll put this white cancel here. And we should be left with, finally, let's put it in red, 3a squared plus 3ha plus h squared. Okay, so we have another kind of difference quotients, and our function is 1 over x. So this would start off with f of x is 1 over x, and then minus f of a would be 1 over a, and then this is all over x minus a. So let's look at what we're trying to figure out here. I would probably just try to subtract 1 over x minus 1 over a. So as I have that, let's try 1 over x minus 1 over a. So the common denominator would be xa. So we have x in a, and we have x in a here. And what's missing in the first fraction is an a, so I multiply that. That would be, a would be here, and what's missing in the second fraction is an x, so we would have x here. So that means we would have a, minus x all over xa. Okay, so that's what that's equal to. So we can use that. I'll write it over here. So that means we have a is equal to a minus x over x a, and that's all over x minus a. Now what we can do is we can multiply both of these by xa. So if I did that times x a, what happens is these cancel, and we're left with this is a minus x over this would be, I'll bring the xa to the other side, so x a, and that has to be multiplied by x minus a. Minus a. Now, what I can further do is a little trick here, and I can factor out a -1. So this is equal to, I would have -1 times, now to keep the numerator the same, really what I'm doing, I'm just changing, see I have a minus x and x minus a, I'm trying to cancel those out. So I factor out a -1, so that means that a is now negative and x is now positive. So I'll just switch those. So that would be x, and then minus a, and that is over this whole xa times also x minus a. And now these can cancel. I'll do that in yellow. These can cancel. And finally, what we're left with is equal to -1 over xa. And that would be that answer. So for this one, f of x is x plus 3 over x plus 1. So like I did with the others, I'll substitute f of x in here and then f of 1. So this one actually should be pretty easy. We would start with f of x is obviously, it is x plus plus 3 over x plus 1. That's f of x. And then minus, and then f of 1 would be, well, that would be 1 plus 3 over 1 plus 1. And then we have over x, so that's just x, minus 1. Okay, so we'll clean this up a little bit. And x plus 3 over x plus 1, I don't know where I'm going with that, so I'll just kind of keep that x plus 3 over x plus 1, and then minus, and that would be 4 over 2, and 4 divided by 2 is 2, so I'll just write 2. And then that's over x minus 1. Now, what might make this a little bit easier is if I call that 2, 2 over 1 maybe, and then looking for a common denominator on that. So I can say that that would be, if I just work on that whole numerator part, that means it would be, this is 1 times x plus 3, and that would be minus, that would be 2 times x plus 1. And that would all be over x plus 1. So when I do all that, that's all over x plus 1. And then the new denominator would be x minus 1. Okay, so if I continue on with that, that is x plus 3 minus, now 2x, I don't know how I'm going to do that, 2 x, and then minus 2. Because if I distribute that, that's 2x, and that's 2. 2 times 1 is 2, you know. So that would be minus 2. And I can combine like terms. So that means I would have x minus 2x. That would be negative 1x. And 3 minus 2 is 1. So, oops. X. 3 minus 2 is 1. So that would be plus 1. I don't even know what color to make it, so I'll just make it 1. And that's equal to, so that's equal to negative x plus 1. And if I continue on, that's just the numerator. So if I keep going with this idea, this whole thing here, remember that was all over x minus 1. So this is x minus 1. And the numerator is this negative x plus 1 over, I'll put red, over x plus 1. So I'm looking at all this coming down here. So what I would do is I would probably multiply this by x plus 1 and multiply this by x plus 1. So these would cancel, and what we have is that's equal to negative x plus 1 on the top. And then on the bottom, we have, I'll put it in red, it'll be x minus 1 times x plus 1. Now on the numerator, what I can do is I can factor out a negative 1, which changes the sign to x minus 1. And then we're almost there. That is over That would be over x minus 1 times x plus 1. And then these would cancel. And I'm left with negative 1 over x plus 1. And so that gives you a great taste of these difference quotients, which is a big part of the entry level of calculus. So I hope this is helpful. That's it.